When we talk about graphing radical functions, we're talking about two separate graphs. The first one that we're going to look at are square roots. So this is something we looked at mathematically in the past. Now we're going to look at it graphically. So this general form equation is given as y equals a square root x minus h closed square root plus k. So very similar to the absolute value, where h and k again make up the vertex, where h is the x value and k is the y value, and h, remember, always opposite sign. A is going to give us some information. Usually it's going to tell us whether this is shooting up or down. It's going to give us direction. Now square roots, I may refer to these in the future as shooting star shapes, kind of follows this square root symbol here. Generally it's going to look like this and kind of shoot off into a direction. So what we're going to do is just do very general graphs of these. So for example, they're going to ask us to graph y equals absolute value x plus 4, not absolute value, square root of x plus 4 minus 2, where the vertex or the starting point is h comma k. H is that inside, k is the outside, and h is always opposite. So we see positive 4, we're going to write it as negative 4. And then k stays the same, it's going to be negative 2. Now up front, we see a 1, and that 1 is positive, so this means everything's going to be fine. It's going to be shooting upwards. So let's go ahead and make a general graph for this. Okay, so we're going to put our starting point at negative 4, negative 2, so that's back 4, down 2. And all I'm going to need you to do for now is make that shooting star shape. This is shooting off to the right, going upwards. Okay. Now because we're going simple on the graph, what we are going to do is talk about domain and range. Okay, so these should be some words that are not new to you. Domain and range. They're telling us what values this graph covers. Domain, remember, is covering side to side. It's the x values. Range covers up and down the y values. Okay, so if you want to make a note of that, and I'll put it here. These are the x values. These are the y values. All right. So for notation here, we want to label domain. How far does this graph go to the left? How far does it go to the right? So if you look at this, we're only looking at the x values here. This graph does stop going to the left. At what x value? That one there, which happens to be a negative 4. The graph continues going off to the right forever. Okay, the number over there in that direction, positive infinity. So I'm going to write it in this notation. So my graph goes from negative 4 to positive infinity. So negative 4, positive infinity. Now if you remember the notation, infinity symbols always get parentheses. Now for domain and range, we're going to use the brackets if necessary. Alright, so at negative 4, this actually starts at negative 4 and continues. So we're going to put a bracket at negative 4 because we include negative 4. It starts at negative 4. It is a closed circle there. If it was an open circle, we would give it a bracket, or sorry, give it a parentheses. Now let's do the same thing for range. Range measures up and down, and we want the low number first. So now we're reading the y values. The lowest this goes down to, and I'm going to switch colors, the lowest this goes down to is right here. That value is negative 2. And does it ever stop going up? No, it never stops going up. The number up there on the y-axis is positive infinity. So this one's going to read going from negative 2 is the small number, positive infinity, parenthesis, bracket on the negative 2, okay, because we can include it. So sometimes we have to graph and do a little analysis on the side. Let's go ahead and take a look at another one. Let's say they said y equals x minus 2 to the 1/2 plus 3. Now this doesn't make too much sense because now we've got something to the 1/2 power. But if we remember back, writing this from exponent form into radical form, this 2 would get brought forward, so we would have a small 2 here, x minus 2, parentheses, exponent 1, and then the plus 3 here. Now what we are seeing is this is a square root. Now we usually don't see the 2 in the front, that's invisible, but it means square root. And then the 1 is unnecessary there. So we can tie this back into the one we just did. This is a square root function, where the vertex is positive 2, positive 3. All right, and up front, a positive 1, meaning it's going upwards. So again, we can go ahead and graph this. This one is placed at 1, 2, positive 3. It is positive, it's going upwards, continuing off forever. Domain and range. Domain, side to side. How far to the left does it go? It stops going left right about here. That number is positive 2. It'll continue going right forever. That number off to the right is positive infinity. Range. It does stop going down at this number. That's 3. And it continues up slowly, but it keeps going up to positive infinity. So there we go, domain and range. Now let's see something where my numbers start to change. Let's say they want us to graph y equals negative square root x plus 2 plus 2. So you'll notice right off the bat your a value is now negative. Vertex though is going to be an unchanged process. That one's going to be a negative 2, positive 2. A value is going to be a negative number, negative 1. So we'll see what happens now when it's negative. If we think about back to parabolas and absolute values, negative signs flip direction for these shapes. So a negative sign, so when it's positive it goes upwards. When it's negative it's just going to go downwards. So we can still graph it the same. Negative 2, positive 2, so back 2, up 2. But now my absolute value shape is going downwards. So it's going to change our domain and range a little bit. Domain. Still measuring side to side. So the farthest to the left that it goes on the x values is right here. Negative 2. It never stops going to the right, so that's positive infinity over there. Range. Now the lowest it goes down to, does it ever stop going down? No. So the low number down there is negative infinity. Does it ever stop going up? Yes, it does at positive 2. And we include it with the brackets. Now, on the other hand, the other radical function that we're going to see is known as cube roots. Cube root functions. And it's going to be very similar. This one, though, looks like y equals. We got the a value. We're going to start the radical, but there's going to be a little 3 in front of it, describing that it's going to be a cube root. H and k remain the same, where h and k, again, give us the vertex, and a is going to give us really the direction. So if I look at these ones, the setup looks very similar, but now the notation with that cube number in front is going to change the shape a little bit. So for example, if they told us to graph y equals the cube root of x plus 2 minus 3. Okay, let's grab the vertex. Opposite of this, negative 2. Keep the k, negative 3. So I'll show you what this graph looks like. 1, 2, 3, 1, 2, 3. So my vertex is at -2, -3. So back 2, down 3. So a good way to start this, maybe just like the square root, go ahead and shoot it off to the right. But when it's cube root, it's also going to shoot back to the left. Now if we want to, we can do domain and range, but you'll notice that it never stops in either direction. It never stops going left, never stops going right, never goes up, or never stops going up, never stops going down. So really everything for this is just all real numbers, or you can write it in the infinity setup. So we're not going to focus on domain and range too much for the cubed root ones, because it's always going to be the same. The only thing that's really going to change is directional. So for example, if it said y equals negative square root x plus 4. So a couple tricky things with this one. The vertex, first of all, k is the inside number, h is the inside number, k is the outside, and I don't see an outside number. H is -4. If we don't see an outside number, or if we don't see an inside number, it's just a 0. So this one's -4, 0. This time your a value is going to be negative. So remember, negatives on the front give us directional changes. So if I go ahead and graph this, my vertex is at -4, 0. That puts us over here on the y-axis. Now when it was positive, I'll make a little note over here, positive made us look like this. Negative is going to flip it. So it's going to go down and up this way. So positive, negative. This time we have negative, so we're going to make our shape look like this. We got it downwards, and we've got upwards. And again, domain and range are unchanged. It goes positive, negative, every single direction. So if you want to go ahead and write it, never stops going left, never stops going right, never stops going down, and never stops going up. So there we have our radical functions, whether it be square root or cube root.